So, hi everyone. Today I'll be explaining my new project which I have made. So, that is a LinkedIn microservice project. So, this is to understand the whole flow of a microservice architecture and also to get knowledge about how microservices communicate with each other, whether it's synchronous communication or asynchronous communication. So I have made this project. So let's go through what all I have used, and also I have used some new DBs. For example, Neo4j DB, which stores data in form of a graph. So which help us to store the users who are connected to each other, first degree, second degree connections we can extract from there very easily, and it is very fast. Also, for communication, I have used Kafka as a messaging tool. So, whenever we are creating a new post, whenever you are sending a connection request or someone likes your post, you will get a notification that okay, so and so liked your post and everything. So, this processing is done through Kafka. So, let me go through each of the things which I have made. So, getting started with the API gateway. So, we have this API gateway. Inside this, we have the filter. So first, when the request comes to an API gateway, it will be authenticated, right? So we have a authentication filter. So inside this filter, what we are doing is we are just using JWT tokens in order to authorize the user. So we are just fetching the authorization from the headers, and then we are basically checking that is the token legal, means is the token legal. And once we get that token is fine, and we extract the user ID from the JWT token. Also, we will be adding, so once this user is verified, so I'll just open the app, means this is basically our API gateway. So this is the user service, then we have post service, we have connection service, and notification service. So the filter which we talked about currently, so this authentication filter we have applied like this. So for user service, we only have two things, that is login and sign up. So that those are public APIs. So we don't have a authentication filter for user service. But for the post service, connection service, and notification service, we have this inside this filter. We have this authentication filter. So whenever a request comes to a post, it will first go through this authentication filter. The JWT token will be verified, and then you will be able to pass through the post service. Also, I have implemented one more thing, that is our auth. Let me open this. So I have made this, which is the service. Let me. This is user service. Okay, acha, okay. Post service. We have to go to post service because user service is means it is. So yeah, so these are auth context holders. So now the basic idea of this is to, whenever a user is authenticated, now whatever request we are passing from there, from API gateway to our post service, what we are doing is we are automatically setting the thread local variable, and inside that thread local variable we are setting our user ID. So by default, whatever user is getting authenticated, this request will have a user ID. Okay, so that user ID we can use in multiple forms, like getting the user credentials from that user ID. So multiple things, right? So what we are doing is we have set up this auth context holder. It will hold a local thread which is having our user ID, and inside that we have this request interceptor. So now request interceptor is implementing this handler interceptor. It has three methods basically. So if you open this, you can see we have pre-handle, post-handle, and after completion. So what we are doing is we have overridden pre-handle and after completion. So when the request comes, we are just setting our user ID, and we are passing the request further. And whenever the request is completed, we are just clearing our user ID so that we do not do any data leaks. Also, for our fiend client also we have done the same thing. So if we are making any fiend client request from our microservice, then in that case also we will be having a auth context holder, that is our user ID. So this is one thing. And then going forward to the features, so as I told you that the user service is only having, so maybe I'll tell you, the user service is only having our, where is the, yeah, this is the controller. So it has sign up and login. So this is the basic two features which user service has. And then so also whenever a user signs up, then what we are doing is we are just creating new ID and everything. So yeah, and also we are generating JWT token for that user. Then what we are doing is inside our post service, if we go to the controller methods, we have post controller and post like controller. So in the post controller, we will be creating the post. So this method will take a request part of post, which will be a DTO request, and then we have a file because user can upload a file as well, right? So we have handled both the things. Then when the post is created, so if you go inside the service method, what we are doing is first we are taking this file and we are uploading this file through our uploader service. Now inside this uploader service also we are using cloudinary, which helps to manage files and everything and host our file to a cloud. So that I'll show you later in this video. And so once the user is creating file, we save this file, then the post is created. Also this post, whenever you upload this post, means image, this file or image, whatever you have, it will generate an image URL. Okay, so using this URL you can access that file. So with the post entity we are storing this image URL as well. Then after this post is created, now once the post is created, what we are doing is basically if you post something, right, so your connections get post request that somebody has posted this things. So what we are doing is we are from the connection service. So I told you, right, we are using this kind of DB. This is a Neo4j DB. So this is basically stores the user. So for example, you can see Sankalp is connected to Ram, Rahul is connected to Ram, Hina is connected to Ram, and Sankalp has connected to this. Hina has requested to Sankalp. This is not yet accepted. So what I'll do is that I will notify all the first degree connection. Now first degree connection for Sankalp is Ram, Rahul. Okay, only two people I have connected to, right? So all the first degree connections will get a Kafka notification, get a notification that okay, this person has uploaded this post. Now what we are doing is we are just fetching the first degree connections from here, and then for each person, what we are doing, we are getting this. So this is a Kafka template we are using. Means this is a Kafka message that we will publish. So we have this post created. We are setting everything, ID, content, user, everything, and then using this Kafka template, we are sending this message to this topic, post created topic. Okay, and then yeah, this is done. So this is for creating the post. And so basically post service deals with creating and everything. Then we have connection service. So let me go to the connection service. So if you open connection service Java, so yeah, auth context holder. So this is a static code which we can place everywhere so that all our requests that are coming should have our user ID. Correct. And then we have controller. So if you go to controller, so see we have this method, right, this endpoint that get the first degree connection of a user. So that's what we were using there to get the first degree connections. Now if you go inside this, this is basically using a normal repository. So now whenever you are using normal the SQL repository, it is similar to that. So this is a Neo4j repository. If you see, we have this Neo4j repository, which is having a person and the ID. So basically, the thing is similar, but this is a graph structured DB, and also the queries are different here. Okay, so this is it regarding the no. So yeah, if we go inside this, we are just fetching our connection, and also inside the connection request we have these endpoints. So send connection, then accept connection. So if you go inside these, so for example, if we send a connection request in that scenario also, what we will be doing is we will be sending a Kafka message to that user whom you are sending the request. So we are having our set of validations that if the request is already exists, or the person are connected, then in that case we should not be sending the request. So once it is verified, then what we are doing is we are just adding a connection request inside our means inside our Neo4j DB, and then this request, this is a Kafka message that we'll be sending. So this is a topic connection requested topic. Inside this, we are sending this request. Okay, similarly, we have accepted. So whenever user accepts your request, the person whose request is accepted will receive a notification that okay, so and so accepted your uh, request. So again, we are doing the similar thing using Kafka. So we have a Kafka template. So next thing is our notification service. If you see, so these messages, see, if we are sending, so I'll tell you the whole procedure of. So see, we have these events, right? So we have these Kafka events. So request accepted, request connection requested. Now these messages we will be processing, and also we have this Kafka config. Now, what is the role of this config? Is this will create a new topic. So this is a bean of new topic. We will just create new topic with the help of this return new topic connection. This is the name of the topic, and this is the partition, and this will be the replication factor. So we have only one replication factor, and this is a partition. We can adjust these settings as we want. So once this Kafka config is set and this event is set, then we are good to send this message. Now using, if I showed you, right, 1 minute, let me go to the service. So we have this, yeah. So if you go to this service, what we are doing here is that event, this is the event, right, which I showed you. This is the connection event. We are setting this event, and now this is the Kafka template. Now, what is the Kafka template? This is just a Kafka template of this our event and the ID, and then we are just sending these. This means through this template we are sending the request. Also, in order to send and receive Kafka, so if we are your producer, then we should have these properties. I'll just show you. So let me open this application. So if you are a producer, then you have should have this. So what we are doing is we are just serializing our data, and then we are processing the message. And if you are a consumer, then we have to deserialize it. Okay, so this is the configuration that we need to send and receive message. Now once we send the message, all the message are received to our notification service. If we open notification service, we might see. Okay, so if you go to services, yeah. So we have this notification service. So the role of this is not much, because what it will do is it will just add a notification into our database, right? So this is one thing, and we also have an endpoint that's called get all notification. Now the main thing is how to consume is under this consumer. So we have connection consumer. So whenever a request means connection is requested, we are publishing message into this topic, right? Now here what we are doing is we are consuming this topic. Inside this, what we are doing is Kafka listener. We have this topic name, and then we have passed this event. If you remember, I showed you just right now, right? That we have this connection requested event. So through this event, what we are doing is we are extracting information, and we are setting this message that you got a new connection request from so and so with the so and so user ID. And then what we are doing is we are just adding this message inside the notification entity, and we are just storing it. So this is how our notification and everything is working. And then at the end, so yeah, so we also have this discovery service, which will be Netflix Eureka server, which will be hosting everything inside our local setup. And if also, if we talk about hosting, so I have also hosted our application inside Google Cloud. So for that we have to set up all our stateful services and stateless services. For example, if we have DB connections, these are stateful sets. So I have set up everything inside this. We have passed the our means the DB parameters and everything. And then we have connection services. Inside the services we have these things. We have a service as well, and then we are passing all our information, for example DB username password, from our environment variable, that is Spring Profile Actives. Then we have a service for Kafka, because when we are hosting, you are hosting in cloud, so you should be having everything. So all this is stateful sets, right? So you have Kafka, then notification DB. All these are stateful sets. These are having some memory resource limits, and then we will be having our, also this will be having a image. Yeah, this is the image. So every service that we are creating, or every stateful set or stateless set we are creating, we should be having a Docker image. So from this, our all the configuration is fetched. So this is fetching the Postgres 16 image. So like that we are creating. And coming to our service, how we have hosted our service, for example, we have our API gateway, connection service, everything hosted inside the cloud, right? So now that we are doing it through our local Docker image. So what we are doing is we are using this. I'll tell you, we are using this Jib plugin. So what just this Jib plugin does is this Jib Maven plugin. Now what will it do is if you have just have a command and you execute that command, your application will be converted into a Docker image, and then it will be directly pulled to your GitHub Docker hub basically. So might be I'll show you later. So we have that, and then so these are the services which helps us to host our application into the Kubernetes, which is Google Kubernetes. And yeah, so I think I've covered everything. No, we have this uploader service as well. So for uploading the image and everything, we are using this uploader service. So we have uploader controller, which is again taking a multi-part form data, and then we have this upload method. So here what we are doing is we are using uh, means we are using Cloudinary, which is basically our hosted for managing our files, videos, and images. So we can upload any image on this Cloudinary, and we can just access that image through a URL. So if you see, we have uploaded this image from this, and then what we are doing is we are just this is a map basically that returns a map, and then from that map we have this secure URL, which is the URL that you will be getting to in order to access your image or video, whatever you have uploaded, right? So if you go to our config, so this also have a config. So inside that we have set everything about the Cloudinary. So we have basically a package that we have to pull in our pom.xml, and then through our package we have to set all these things, that is cloud name, then we have API key, API secret, everything you will set inside this, and you'll form a bean. And using this bean we are just creating or uploading our image. So yeah, so that is pretty much about these things. So I'll not be running this project because it is very heavy and it will be, it will lag a bit. So yeah, this is it about the application. This is all the service which I have made. So yeah, thank you.